Introduction to Control Systems by Mikhail Boretz, Tamir Sarkhan, Adi Walach. Purpose and field. Engineering is concerned with controlling natural systems by controlling systems that requires understanding and analysis to get the ability to model it by accurate math equation. The purpose of control engineering is to control complex and modern systems. Particularly, control engineering is based on linear systems. Also, this engineering doesn't limit it for a specific field. It can be relevant to aeronautical, chemical, mechanical, environmental, civil, and electrical engineering. Systems tend to return or remain in equilibrium without external interfering. This is the definition of stability. In our world, we have two types of systems. The first type is unstable system. The second is stable system. The difference between stable and unstable system is the desired endpoint. Stable system is a system where the endpoint is the desired endpoint. The control goal is to take an unstable system and transfer it to a stable one. This image is the example for unstable system. If you just leave it would never stay at the beginning point. The second one is for a stable system. In this system, it would always go back to the beginning point. Open and closed loop. There are basic components in systems, like process, the ratio between input and output. The second component is feedback and controller. We have open loop and closed loop systems. Open loop is a system without feedback. Closed system is a system that contains feedback. In other words, system with control loop. The controller corrects the output till the desired point. Feedback. Feedback is a type of sensors. We use sensors in our daily life. For instance, GPS is a common sensor that returns the position. The second one, meter weight sensor, returns the weight.
History. Using control system started from the past and happening until these days. The first application of feedback control was the development of float regulator in Greece in the period of 300 BC to the 1st BC. It was called the water clock of Kotzebue by the name of its inventor. The water clock was constructed by a tank of water with an oil lamp that was floated on the water, and the lamp was lighting fire, and it was possible to see where the lamp is situated and know what is the water level. The first automatic feedback controller used in an industrial process called the flyball governor. The device was measured the speed of the output steam from the shaft of an engine. As the speed increased, the flyball went up, and therefore they know what is the engine output. A large development of the automatic control theory occurred during the World War II, when it became much more necessary to design and to construct the automatic military machines like automatic airplanes pilots, as you see in the pictures, and gun positioning systems, and radar and telecontrol systems that we have in the picture as well. And the other military systems based on the feedback control systems. Prior to the 1940s, for most cases, the design of the control systems was actually an art that involving the trial and the error approach. The 1980s was represented by digital systems and computers that calculate everything and makes the control systems much more accurate. The reliable of those systems are done it formers the former systems. With the advent of the space age on the 1990s, it became much more necessary to design the complex and high accuracy control systems for missiles and space probes. And furthermore, the necessity of to control satellites has required the developing of the important field of optimal control. The methods of this field was got highly interest in the now it's much more clear to see that control engineering must contain both time and frequency domain approach simultaneously when analyze and design control systems.
In order to really understand the control system, we have to look at a few examples. First example is a fuel tank. You can see there is an input to the water, to the tank, and the actual man can control the valve taking the water out. So now he looks with his eyes and he can see the level. And by turning the valve, he can control exact level. It will take him some time and practice, but after some time he will manage to understand exactly how much he has to turn the valve to make sure that the level stays always on the same level. To get a machine to do the same thing, like we can see in the chart, the machine can have a sensor, a computer to calculate, and an electrical valve instead of the hands. In such a way you can really control it. The only difference is that a human can learn it on his own, and the machine has to be taught by humans. A very nice example of a control system that only a machine can do is the following one. It's a triple pendulum. You'll see now in the video. It's quite amazing if you think about it. And you try to hold the triple pendulum into one straight line in the middle. Moves and makes sure that it stands straight. Now if you think about it, a human after a lot of practice will never manage to get to such a straight level and hold the triple pendulum straight. The system was built by humans after calculating the exact physical equations to make sure it can stand in the right position. There you see two graphs. One of them you can show you that when it's like the position on time. So now it takes him a bit of time and he gets to the right position. It's called after the machine was stable. And if the machine is not stable, it moves from one side to another side, from one side to another side without really settling into one point. Another very good example is a car. When we drive a car, we don't really notice that we have a steering wheel. If we don't, even though we try to get to a certain direction, the car can really, computer control in the car can let the car get to the right position. In other words, if you turn your steering wheel too much, regardless to the speed of the car. So the actual computer can evaluate the right position you were intended to by controlling the system. So the way it works is the following. You've got measurements. You've got the driver indicates. It tells you, the driver says I want to go certain degrees right. And then it goes into the computer, the automatic system, and goes out. But the system, the measurement also comes in and makes sure it doesn't move too much or too low. In the graph you can see that the actual direction is a green one, and the desired direction is a black one. So if you when you turn the steering wheel, it looks like this. But after the control, it makes it in a nice black and straight direction for the car to drive in a much decent way. By the way, that's the reason the new cars, after they got the best control systems, you can go in very high speeds, even though a human cannot really calculate the right position of the steering wheel. Sorry, the future of the beginning of the future of controlling systems comes from two different aspects: the flexibility and the autonomy. It started on two different. First, we got like screwdrivers, let's say, first one, and the hand tools. It started from first mechanical systems, and then we got, let's say, to a drill, and one way, and other way it was like certain measurement tools, like laser tools to measure things, or ultrasonic or other measurement tools. Slowly it became more and more sophisticated, and we're heading to one main goal: intelligent systems and flexibility systems. Intelligent systems would be flexible and also would be able to teach themselves how to do certain things. Like you see here, you've got the vision. The human-machine interface is on one, flexibility. You've got a human-machine interface, very easy to change. And on this side you can see you've got higher level of sensors, you've got language, and you've got the most important factor is artificial intelligence. So if you combine artificial intelligence together with vision, and then you get extensive flexible and autonomy machines. The last thing, like I said, will be the intelligent systems. So like you see, finally the future of control system will provide us all great entertainment with robotics doing the best music you can even think of, even though it will be quite different, robotics playing as music. Thanks.